Okay, so there we have three different approaches to this that you're outlining. Is the modified gravity as one way to go. There's this emergent picture of trying to reframe the idea of gravity to begin with, and then you have quantum gravity. So to the three debaters here, if you had to place your bets, Priya, on either of these, you say you're agnostic, but if you had to put some, if I gave you some chips now, you had to put them down on the table.
So what's the third option? So I think modifying gravity just with a view to adding additional degrees of freedom, but stay within the same framework where other cracks are opening up is clearly not, that's not where I would put my bet. But not little tweaks to the theory, but push it so that the cracks, to try to make sense of all these crises. So the modifying gravity so far has been really focused on the dark matter problem. So new, and I think as Sabine pointed out, new zoos of particles, right? Alternative particles. I think that's an approach that has been tried. A lot of energy has been spent, and I think it's been useful. It's taught us more, but that's not where I would put my bet on. The kind of pushing the theory that I'm talking about is actually trying to see these crises, going beyond just having a different kind of dark matter particle. I think that's where things are pushing us. Fundamentally look at the nature of dark energy and what we think dark energy is, for example. And then fundamentally looking at whether these conceptual ideas of dark matter and dark energy can somehow be, could they be two manifestations of the same thing? I think those kinds of ideas are totally worth exploring, and I think they should be, and not as much attention is being paid to them. We've been spending too much, so I would not bet on the modifying gravity. And I said with the quantum theory of gravity, I think that there's just like vast bits of things that we don't understand. So as a pragmatist, I would stick to sort of my view of really pushing the theory of general relativity with the view of finding a replacement theory for it. And I firmly believe that we will see new directions.
But Sabine, this approach to modified gravity, which has come to the fore a lot in the last 5 to 10 years, it's really gained a lot of interest and a lot of research in the field. I know you have also engaged a lot with that field. Do you see it, as Priya is suggesting here, more that it's limited kind of tinkering with the existing model, or do you think that there's a real promise in a kind of a breakthrough with understanding modified gravity?
Well, as you say, I've actually worked on modified gravity for a couple of years, and I used to think it's really promising, it's going to solve all these problems, and I don't work on it anymore because it turned out it doesn't work quite as well as I thought it would. It's like, from a theoretical side, it's really, really difficult to make those theories work. And I'm of two minds about this. On the one hand, they do have some really appealing properties where you can explain certain types of correlations that we observe, like as a matter of fact. We can explain them very easily. But on the theoretical side, they don't seem to work properly. So, and this, I'm afraid I actually agree with you. It just makes me feel like we're missing something really big. Yeah. Like there's something fundamentally wrong with this type of theory because they don't work. With the mathematics doesn't work the way that we expect it to work.
Especially light deflection. I think one of the big, I was open-minded like Sabine. I dabbled a little less because I'm invested in light detection, gravitational lensing. Those theories are unable to provide a description, and we see these lenses, we see these arcs. Hubble Space Telescope has shown us these arcs, right? So,
there are models which can explain that kind of thing, but then they have other problems. So it's like you're pushing around the bump under the carpet. It always comes up somewhere.